Yep.
All right, so we'll give people a second here to hop on. I can't get over how gorgeous that weather is. It's perfect.
Blue sky. It is. Beautiful.
Hello, folks who are joining us. We're just going to give people another moment or two, and then we will get started. So thank you to everyone who's hopping on. We're so excited to have you here. And just a moment or two, and then we will kick things off. Your sky looks bluer than my fake background. Whoa!
Anyone getting dizzy?
You didn't tell us this was going to be something we had to take gravel for in advance.
Okay, I'll stop.
Hello, folks who are joining. We will get started in just another moment. Thank you for tuning in. We're excited to have you here. Yeah, so happy to have her. So happy this all worked too. Technology so far, I shouldn't say that out loud, but so far so good, right?
Mm-hmm.
Okay, so maybe what I'll do is I will get started briefly. So welcome everyone who's joining us from near and far, we're not sure, to this webinar. So this is a live Zoom conversation between the Canada Aviation and Space Museum Science Advisor, Dr. Cassandra Marion, and myself. My name is Ariane Richardson. I'm with the Ingenium's communications team. I'll be, I guess, your host this evening. I identify as she, her. I have kind of blondish brown hair, pale skin. I'm wearing a blue shirt with black polka dots. Both myself and the museum are in Ottawa, and in Ottawa we are located on the unceded territory of the Algonquin Anishinaabe people. We certainly appreciate the chance to work and learn on this land. In a few moments, you will be hearing from Dr. Marion and having a chance to learn about her location and the research the team is involved in on Axel Heiberg, Nunavut, Canada. Just a few really quick housekeeping notes. This presentation is in English only tonight. Happily, we will be linking up with Cass tomorrow evening at 7 p.m. again for a similar presentation in French. So feel free to join us then if you would like. We're going to start by hearing from Cass. Later on, there'll be an opportunity for me to relay your questions to her. We will have a hard stop at 7:50 because Dr. Cass needs to leave us for a radio check at that time. I am recording this webinar, and I do hope to post a link to the video on the museum's YouTube channel as soon as I'm able. And finally, just a note, we are somewhat at the mercy of technology. As you know, Dr. Marion is in a remote area and it's thunderstorming here in Ottawa. So we both have our potential challenges. We're gonna cross our fingers that everything goes well. If Dr. Cass cuts out, she will try and rejoin us. So please stay on if that does happen, and we'll try to kick things back off. But I believe that is all from me. So I will take a back seat for a while and let Dr. Cass tell us about where she is and what she's doing. Thank you so much for joining us.
Thank you. Thanks so much, Ariane, for that wonderful introduction. So, hey everybody, I'm Cass, like Ariane said, Science Advisor, and I'm joining you from Axel Heiberg Island, which is in the Canadian High Arctic. We are at 79 degrees north, so take sort of the distance between Ottawa and Iqaluit and double that, actually triple that, like once west and once north again. That's about where we are. So we're pretty far in the middle of nowhere. These lands are the traditional lands of the Inuit, but currently Axel Heiberg Island is not inhabited. But this station is the only place, like where we're staying right now, called the McGill University
Arctic Research
McGill Arctic Research Station. So I've got some teammates here that are helping me out. If I forget anything, they'll make sure I fit that in. So short, we call it MARS, very conveniently. And so this is the only place that's really partly inhabited part of the year on the whole island. And so I wanted to, Ariane talked about our connection, and I wanted to point out that we're actually connected right now through space technology. I can even point it to you. I'm going to switch my camera around, and up here on this building, way up there, boom. Actually, wait. Starlink satellite dish. So thank you, SpaceX, for connecting us this evening. So I thought I'd start off by giving you a bit of a tour of where we are living. And then after that, I'll introduce you to the team and we can talk about some instruments, maybe do some demos, and you can ask all the questions you like. So if you throw your questions into the comments, Ariane will send them our way at the end. All right, so I mentioned the station. It's been here since 1960, and the main reason it was built was actually to monitor glaciers. We're actually camped right next to White Glacier and Thompson Glacier, and White Glacier is one of 40 that are 40 glaciers on the planet that are monitored for global change. And so I think you'll have a decent view of it. If I walk over here, if I freeze a little bit, it's just because I'm coming out of range of sort of the bubble of my internet access. So I'm going to turn the camera around so I can give you a really good view. Hopefully you can see that. So down in that valley, I'll zoom in a little bit. So the little one to the left, there you go. Little one to the left is White Glacier, and it kind of goes up to the left. And then most of the ice that you can at White, that's Thompson Glacier. It's a much larger glacier. And then our home sweet home up on that hill up there, I can attempt to walk up there. That's where we're sleeping. Everyone has their personal tent. There are a couple of people that are in what's called weather havens, like this one here. Anthony, one of the other researchers staying at the station, stays in that one. And so we're just in expedition tents on the top of that hill. So every time we want to go to bed at night, we have a hill to climb. I probably won't get up that hill. I'll probably lose you first. But you can see how steep it gets. As I get closer, it's deceiving from far away, but it's actually quite the climb to go to bed. But you open your vestibule, and that's your view. The bathroom is also, you'll see this trail. Zoom in a little bit. If you can see that trail there, that actually goes around the hill, and that's bathroom number 1. And it's basically a bucket with a lid, and you go number 1 on the ground and number 2 in the bucket, and then we have an incinerator that burns it all up. Our second bathroom is literally a porta potty, but again, it actually is connected to a tube that runs the number 1 right into the ground. And again, any paper products or whatever, we actually put in a bag and we incinerate them later. So no waste, unneeded waste stays here in the Arctic. Looking around, I'll give you a bit of the tour of what buildings are here. The building right in front of us is what's called the hut, or the upper hut, and it's basically half laboratory to the right side, and on the other side there are bunk beds. So there are a couple of people, some scientists staying in the left side of it. It's one of the original structures here. There's another one down the hill, and point uphill a little bit, you also see there's a large antenna. That's a UHF radio antenna that lets us talk to Resolute, the Polar Continental Shelf program in Resolute. They're really the base of logistics operations here in the Arctic. So any work that any scientist wants to do on any island in the Arctic goes through Resolute. They're the ones that send the planes, the helicopters. They can support you with gear, etc. So they're very helpful folks. And that boxy structure up there is a kitchen. It's pretty much a normal kitchen, except for everything runs on propane. So we live in tents, but it's a bit of a luxury camp since we have a real kitchen. That said, we'll only eat dehydrated food because we had tight space on our plane on the way up, and it was hard to fit everything on the plane because it's got a weight limit. So we're allotted 2,000 pounds to put on our Twin Otter, de Havilland Canada Twin Otter plane, which is a short takeoff and landing plane, a stall plane. And I'm going to show you where it lands to get us here. So that 2,000 pounds I talked about, that includes all of our team and all of our gear. And it's not very much. When you have 6 people, they already weigh over 1,000 pounds. So you have very little to work with when you have 2 weeks of equipment and personal gear and food. So we had to reduce some of the weight we had brought. On the way here. All right, so now I'm going to give you the different view. Switch again. All right, so they're kept out on a lake. That is the source of our drinking water. Interestingly enough, it actually has a pH of just under 4, so it's pretty acidic water, but so far my teeth have not dissolved, but it tastes really good. And you can see, looking back, I'm looking into the sun, so I apologize, it's a bit of a glare. But if that tiny corner way back there, that actually is the end of the fjord, which runs into the Arctic Ocean. So coming back to the lake here, you'll see the terrain on this flat area, if I zoom in a bit, is full of polygons. That's a geological form, that feature that's created by the freeze thaw of the permafrost up here. So you can see there's just these sort of squarish polygonal shapes in the ground. And if you look close enough, it's kind of tough to see, but if you follow those fuel barrels, you'll see that there is a roughly linear feature, a straight line, and that is where the plane lands and takes off. It has to come through either this valley and land this way, and sometimes it takes off in between these two very narrow hills and takes off or lands in that direction and then turns around and heads to Resolute. So that's the tricky way. Now you might notice, it drops everything off on the landing strip, but then we have a lake to cross. We actually have to literally put waders and very tall rubber boots on and carry everything across the lake about there. There's a little path through, and it's about a little deeper than knee deep. You have to carry it across and then carry it all the way up this hill. You leave your kitchens, your food there, and then you bring all your personal gear and tents up on that hill way over there. All right, so I'm gonna turn back to me. There we go. Still hear me all right, Ariane?
Yes, it's perfect. It's perfect. We
Awesome.
hear you and we see you. It's great.
All right, I'm gonna turn away from the sun. So, all right, so that's basically camp. A little introduction to the types of rocks that we've got here, because there's quite a few. Most of them are sedimentary rocks or metasedimentary rocks. So like those that are on that big mountain are made up of sedimentary rocks that have been uplifted and built into mountains. You'll see there's lots of glaciers around. Then we also have what's called igneous rocks. So those are rocks that crystallize from a melt, and they actually form a lot of the hills around here. There are diabase or basaltic dikes that run here. And then this big mountain, the one that we are camped on, is actually a salt dome. They're called diapirs. And these salty rocks, very gypsum rich, sulfate rich, uplifted and kind of pushed its way through. They're much older, and they were deep-seated rocks, and they pushed their way through and snuck up to the top of the mountain chain. And if you look in the distance, you can actually see a mix of all three of those rock types in the mountains behind our crew here. So the folks that you see in front of me, that is entire TMARS crew. So now I'm going to come over and introduce you. So walking up the hill and escaping over there, that's Levin. He's a little shy. And then we have Gaëlle, Richard, Éloise, and Myriam. So I'm going to hand the camera off to Éloise, who's going to graciously help me out. You're going to turn your mics on. Dun, 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 dun. We move out to oh yeah, we can move just a little bit further so that it should have to hear the generator. Oh, okay. There, perfect. Do you want to just do a little sound check? Make sure that we're on.
Check. How's the sound? Hello, on and the rest of Canada.
We can hear you. It's a little muffled, but we can hear you. Maybe if you stay like one step closer.
Okay. How's that?
Yeah, that's great.
All right. So Myriam is the principal investigator of TMARS, our project here today. And I think I'll turn it over to you to introduce yourself and TMARS.
Yes, thanks, Cass. So I'm Myriam Lemelin, professor of applied geomatics at the Université de Sherbrooke. And I have assembled an amazing team to help me out studying rocks here on Axel Heiberg that we think may look like rocks on Mars and may have hosted life in the past, perhaps. So we have Richard Léveillé, You want to introduce yourself?
Hello. So I'm Richard Léveillé. I'm adjunct professor of Earth and Planetary Sciences at McGill University and professor of geology at John Abbott College. And I'm collaborating with Myriam and the rest of the team. And I guess my specialty is looking at signs of life that we might find preserved in the rocks. And this is an activity that we try and do on Mars. So we have rover missions that are there now, studying rocks on Mars, very old rocks that were formed at a time when Mars was much different than it is today. Today, Mars is a cold, dry place. And in the distant past, it was much more Earth-like. So we're doing that on Mars, but it's of course complicated and very expensive. And to help understand some of what we find on Mars, we do studies on Earth, which are the sites are much more accessible, like this one, although it is still quite remote. And that remoteness actually contributes to it being an interesting place to go to. We don't want to study things in the backyard at our homes in Ottawa or Montreal or so this is a very interesting place that we can come and learn things that can maybe influence future missions to Mars or help us to understand the results that we're seeing on Mars.
Yeah. So I can explain a bit about the project. So our group name is TMARS. So TMARS stands for Terrestrial Mineral Analysis by Remote Sensing. So our project involves three main steps. The first step is done by remote sensing. So we use satellite imagery that's acquired in Earth orbit to map out the area before we come here, just like is being done on Mars. Then we try to understand the geology and look for interesting places that may host life or may have hosted life on Mars. Then we come here for the second part of the project on the field with portable remote sensing instruments. So we use them to acquire knowledge about the composition of the rocks without actually having to destroy them or bring them to the lab. So we have a first idea of what we're seeing on the ground with these instruments, as could be done by the Perseverance rover, for example, on Mars. And then once we identify samples of interest, then we collect them and we bring them back to the lab for further analysis, as we would do for a sample return mission, for example.
Perfect. Did you, since you have it in your hand, did you want to
Yeah.
describe what's in your hand? You want to hold that for me?
Yeah.
Absolutely. So the idea behind most of the remote sensing instruments is that they can detect light that's being sent by the sun toward the surface and reflected off the surface, but light that we are not able to see with our eyes. So our eyes are able to see a wavelength in the visible region of the electromagnetic spectrum that's sent by the sun. But we also know UV light and infrared light, for example, that our eyes are not able to see, but these instruments are able to. And each target or each rock will reflect light differently. So when we use this instrument to measure the light that's being reflected from rocks or surfaces, they each have their own signature, and that's how we're able to identify them.
And so following up on that, can you, Richard, explain what a biosignature is and sort of how we can identify them using those instruments?
Right. So a biosignature is basically, as the name implies, a signature of biology or a signature of life. And that could be a number of different things. It could be, if you think of a fossil, you know, the fossil of an organism, of a dinosaur or whatever, that could be a biosignature. We don't think there were ever dinosaurs on Mars, but there could have been maybe simple microbial life like bacteria, because we know that there were lakes and rivers way back in the early history of Mars. So those are maybe the kinds of things we might expect to find. So the remains of, say, a bacterium or organic molecules, carbon-based molecules that may have been left by a bacterium when it died and got preserved, say, in a sediment, in a lake sediment. And today that sediment might be a rock, and we can go and collect that rock and look for various signs of those past microbial organisms. So that's the general idea. It can get quite complex. So we look at things like carbon isotopes or organic molecules like lipids, and then specific kinds of lipids, and that can tell us a lot of information. So it's quite complex. A lot of that is done in the laboratory, where we have very large and sensitive instruments. And in the field, we could potentially determine or detect molecules, organic molecules. They are abundant enough, just like on Mars with the Perseverance rover. It's possible. In fact, they just announced, the team announced that organic molecules were detected in Jezero crater where the Perseverance rover is exploring. That doesn't mean those molecules are from biological organisms, because there's other ways you can produce them, but it's still a good indication that the rocks can contain organic matter or organic molecules, and it might require further analyses in the lab. So the idea is that, you know, with these instruments in the field, you know, we can certainly look at the right rocks with the right minerals, and maybe we could find indications that there might be some biosignatures, and then we would maybe confirm that in the laboratory or do some more detailed analysis, confirm our ideas and our hypotheses.
Did we already talk about what a Gaussian is? I'm not sure if you dabbled in that.
No, that's true. So
Not really, yeah.
I just said that we're looking at rocks that may be similar to rocks that can be found on Mars, but that's true. So we're looking at one specific type or family of rocks that we think could be present on Mars. So these are Gaussians. So there are multiple ways Gaussians can form, as we can see here in the field. But basically you have an intrusion of sulfur, rocks that contain sulfur, that come into contact with water and oxygen, and then they oxidize and produce a variety of other minerals that are rich, or they differentiate the sulfur and the iron part, which microbial life can live in or thrive in, potentially. So we're looking to find these rocks, and this region has a high density of Gaussians. So we can study a variety of them in a relatively close, enclosed perimeter, which is a very special place in the world for that.
And so, and Éloise behind the camera, her project is basically focused on identifying these. So they've used the satellite data to identify them. So on this, standing on the ground, you see that there's, you know, a hump of rusty, ugly orange thing sticking around, and that's basically you're almost guaranteed it's going to be a Gaussian when you come up close, because it's very iron rich deposit underneath. It's interacted with water and now has made it this crusty, rusty looking thing. And so she's identified those from satellites using fun approaches and new approaches. And then we go and hunt them, and then Gaëlle digs them up for sampling so that she can find some biosignatures in it. So it all comes full circle.
Yeah, and Gaussians are not necessarily easy to identify in remote sensing images either. So before we came here, we had a clue about where they could be, and in other areas we weren't sure if there were there or not. So we have to walk quite a bit to verify our maps, see if we were right or wrong. And then when we're right, we're happy, and we dig them to identify the mineralogy in more detail.
Yep. All right. If anyone would like, did you want to add anything else on that before I do a little thingy?
Maybe one more thing.
Yeah,
so we do have some students working here. They're a little bit shy tonight, but our project is partially funded by the Canadian Space Agency. And part of that is to train, you know, young students or you know, developing scientists for the next generation of Canadian scientists who will contribute to both science on Earth, but also potentially science and technology that may go to Mars or other planets or other places in our solar system.
Yep. Thank you, CSA, for funding things for many, many years. I think just hang on to it for a few minutes there. I also wanted to say hi, Mom. I know you're watching. I'm going to another one of the instruments. So I guess my role, I never actually introduced my role on this. I am the museum science advisor, but in this circumstance, I'm wearing hat of field lead. So just guiding logistics and making sure the team stays safe while we're up here. But I also get to be the kind of the context camera for the master students' research work. And so I get to take photos. So I have the drone here, and we can do a little demo and fly the drone a little bit if everyone's game. And then we can hit some questions after that. So if you just stay there, Éloise, you can turn towards me, but I will have to step a little further away so that no one gets you know, a drone flying too close. But it is an ultralight, so I'm A-OK. Pocket. Je vais faire le tour. All right. Doo-doo-doo. So I'll come up close and just introduce you to what this guy is and looks like first. So thanks to Ryan for purchasing me this drone before coming up here. This is a DJI Mini 3, and you can see it's got little tiny blades there, 4 sets of them. And then I put this cage on here so that, you know, if I'm a very bad pilot and I either hit the rocks or land crooked, or the team is a bit too close, no one can get hurt and it can't get hurt either. So big plus there. So I'm gonna back away now, and once it's happy, I'll try and take off. I'm gonna get away from some wires.
Yes.
So you probably won't be able to hear me very well, but I'll just fly it a little bit.
We can still hear you, actually.
Can you still see me?
Yes. See and hear. Yeah.
Je parle tout avec les deux chats. Probably. And I will take a picture of you while you're videoing me. And then take it off. So the best thing about this,
Oops. Okay.
ça va?
Ouais.
So the best thing about this is it has a camera on a little gimbal, so it stays really stable when we take images and videos. And so when we're scrambling on the rocks and the team want to, you know, check out to see if there's a gossan on the side of a cliff face that's quite a ways away to hike to, we can just send the drone to check it out, do a little recon first, and come back and then check out if we go. And then the other thing is you can get really an aerial view or a better sort of a wide angle view of the outcrop, because their work is basically, you know, with their head in the dirt. So they're getting all of these different scales: head in the dirt, drone, and satellite. So it all comes together again. So I'm just gonna set this down. Turn it off so I don't kill the battery. There you go. And we won't walk on it. So Ariane, is there any questions in the comment box yet?
Okay, so folks, I'm gonna see. I don't see anything quite yet. I might get the ball rolling actually, and then we'll see if folks pop on with a question. So I have to start with an aviation question. I hope that's okay. I know that's not the focus of your research, but it is the Aviation and Space Museum, and there may be some aviation enthusiasts who are watching. Can you tell us a little bit about the interaction you've had with aircraft in getting you to the spot that you're in? What have you been flying in, and how has that gone?
Sure. So we flew commercial Canadian North. Thank you, Canadian North. From Ottawa to Iqaluit, Iqaluit to Arctic Bay, Arctic Bay to Resolute Bay, all in one day. They were very smooth flights.
Yep.
I'd say. Yep. And they always have those really warm cookies that they heat up. It's like the best thing for Canadian North. And
Different plane.
what's that?
2 different planes.
2 different planes. I know that the last plane was an ATR. So yep, it's an older plane, but they're still going strong. And then once in Resolute, we reorganize our gear and we have a charter on a de Havilland Canada Twin Otter that flies into here. So it actually can carry about 20 people, but because the seats away and we put 6 people in the back of the plane and cargo basically strap our gear right at our feet, and it's sort of separating us and the pilots. That's how we got here. The pilots themselves, they were 2 women, amazing pilots. The main pilot was Lindsay, and the co-pilot, Bailey, I think. Yeah,
Bailey.
Lindsay and Bailey. There you go. Did a fantastic job and got us in here safe and sound. And hopefully will help us get out of here safe and sound too on the 22nd.
Actually, packing to come here from Resolute to here was similar to a space mission because we had a limited amount of weight that we can carry on the plane. So we spent a day and a half packing our gear and then listing the things that could be removed if the weight was too much and weighing everything. So we had to compromise on the things that we brought here to fit under the weight limit of the plane.
Yep, that 2,000 pounds that I mentioned there had to be dead on. We weighed every last thing.
I realized I was muted. Not an easy feat. Speaking of aircraft, I can't get over the bugs. That's wild. They look as big as planes. Yeah, you guys are so calm and unfazed by them. It's amazing. Okay, we do have a couple of questions, so I'll jump to those from the audience. So, question from Joanna, who asks, "Why is your camp so spread out?"
Good question. So, like I said, this camp was built in 1960, and so as they were adding bits and pieces, they were adding it in probably, so the first hut I think was built down by the lake. It's the oldest building. Then they realized it's really wet down there, doesn't get a lot of wind, and so it wasn't a great spot. So they decided to move up on the hill. And then at a certain point, actually more recently, they built the kitchen. In the kitchen, any food, right? We're in the Arctic. There are a lot of wildlife here, including potentially polar bears, wolves, etc. And you want to keep any food items really far from where you're sleeping. And so often down that lower hut and this hut here, which are the first buildings, that's where they were sleeping. So they wanted the kitchen away. Same thing with the tents. That's why they are well away from pretty much everything else that could maybe attract some animals. That's one of the main reasons it's spread out. We also have some fuel barrels. Those are also really smelly and can attract animals, particularly bears like the smell of gas. So that's why those are well away from the buildings. And then the weather havens, I think they went up just where the flattest spot was.
Excellent. Okay, great. Thank you. We actually have quite a few questions, so I'll get to the next one. Julie asks, you mentioned students, and she's asking, what level of education are they in? Bachelor of Science, Master's, PhD, etc.
Yeah, good question. So on the field, we have had 2 expeditions last year and this summer. Master students came in last year and this year. And for the remote sensing part of the project at the Université de Sherbrooke, we also have undergraduate students helping out preparing the remote sensing images and the cartography that's being done on the computer. They can also help out with the samples that we bring back to the lab, so they can help our master students analyze their data. There could be PhD students as well, but for now we've had undergraduate and master level students.
And right now the camp is pretty busy. There's about 17 people. So there are some other teams that are here working on projects that are completely different, from ecological monitoring to glaciological studies. Even some astrophysicists are here installing antennas for their microwave telescope, which I won't say much about. But we do have undergraduate students, master students, PhD students, and postdoctoral researchers and professors and a number of other people. So it's quite diverse.
Very cool.
If I may, Ariane.
Yeah.
I'll add to that. This site is for decades now has hosted, so all basically what they like to say is all the ologies. So all of the natural sciences, all the planetary scientists, there's so much here that is unknown and is still left to be studied. And so every kind of scientist is welcome to come and check it out and open new doors.
Sorry, lost my mute. Excellent. Thank you so much. All right, question from Fern, who's asking, has there been a noticeable change in the ice level since the original data in 1960 when the site was set up?
Yes, a significant change. I can't remember the exact number, but several tens of meters. So the smaller glacier, White Glacier, it's actually receded quite a bit and has been receding since they set up camp. There's actually the main glaciologist, Laura Thompson, that's usually here in the spring every single year. She said, you know, that's, like I mentioned, it's one of the best monitored glaciers. But she had mentioned that there's actually a little, she showed us the peg where it was quite a ways down the valley. I'm going to guess some 60 meters at least. It has receded, but not only receded up the mountain, but also the thickness of the glacier itself has thinned significantly and thinned widthwise as well. So you can see at the end, there's a terminal moraine and lateral moraines, the ones that are along the sides, and the height of that moraine is now higher than the glacier. So that means at some point the glacier was higher than the moraine because it was feeding into it, and now it is below what it used to feed into. Which is an incredible amount of melt. I can tell you now that the fjord, which is in the spring just a trickle of meltwater, is now flowing and is a giant river filling the fjord. Today we were down there checking out some rocks and checking out some cold springs, getting the tour of cold springs just yesterday. Thompson Glacier, the bigger one, because it's so much bigger and it is there's so much more ice, it tends to have a very slow reaction to the actual climate, like the present day climate. And so it actually was advancing up until fairly recently and is now just starting to recede in the last couple of years. As I understand, because I'm not a glaciologist, I'm just repeating what the glaciologist told me last year.
Perfect, thank you so much. All right, we have a question from Mark, who's asking, what is the weather like during your stay? It looks gorgeous, but have there been other variations?
Yeah, so we've been lucky. Since we've arrived, the weather has been like that pretty much. Mostly sunny, day and night. The sun just circles above our head. So yeah, we've been very lucky. Bugs are quite present, but they're not too, they don't bite that much, so it's been great. But the team was here last year as well, and apparently it's been very different. So we're lucky this year. How was it last year, Cass? Cass was there too last year. I wasn't. I was on maternity leave.
Last year was a very, very different experience. We landed, well, actually, we were delayed in Resolute for 8 days. We were supposed to be in the field a week longer than we got because it was fogged in and there was a huge sort of this gyre system circling around and just wouldn't let up. And now we have this beautiful system that won't let up, and we hope it continues. But they finally got us in, and then it rained on us, and we were, you know, we had a helicopter that brought us. We actually camped at a fly camp about 4 kilometers north of here, up next to the glacier. And a helicopter was sort of ferrying us back and forth. We were filling it with gear and getting sort of one teammate at a time over there. And by the time the last trip was happening, it was pouring rain, and I could barely see where we were going. So we got in and we had to set up our tents in the rain, and we had 2 people holding tarps so they wouldn't get wet, and 2 other people underneath trying to get the tents up so that everything stayed dry for sleep. And then it was quite chilly for the next couple of days. I don't think we had temperatures over, say, 10 degrees, Éloise?
Maybe 15,
Maybe 15
one day or two.
I think we had one sunny day, and the rest of the days it was a mix of drizzle and fog and wind. But this time, you know, we had 2 really good science days last year, and this year we've had, every day has been a good science day. We've just been getting things done left and right. Big change. I should mention, we were supposed to, when you asked about the aircraft this year, we were supposed to have a helicopter. We were supposed to do some helicopter work farther away, but that got canceled because there was an unfortunate incident that made the helicopter unavailable.
All right. I have a feeling from someone you may know. Cass, this is from Hannah, who says, as your best friend, I did not know you were a talented drone flyer. But there is a question in here too. Part one, how far can you roam with it? Is that how different from how far you feel comfortable letting it go? And are you looking for orange rocks only? Is that color quite easy to spot on the video screen, or are there more clues that you found what you're looking for?
Hi, Hannah. Love you. Yeah, so the drone connect, it's actually pretty, it can go pretty far. So the connection, as long as you have line of sight, it can probably go a couple kilometers, to be honest. Am I comfortable having it go that far? Definitely not, because I don't want to have to go and get it and try and find it if it crashes. It does. It's really smart though, because if it does have sort of a crash landing or hit the side of a mountain, you can, like with the remote, tell it to start like letting off a signal and beeping, so it's easier to spot it. But if you're a kilometer away, you're not going to hear that beeping, and you're just going to be scouring the landscape forever. So we keep it pretty close, and I will say we have had some pretty high winds, and so I have had to keep it really low to the ground or just not flying at all during those days. But thanks for the props. But yes, so we're not just looking for the rusty rocks. That's the focus of what's being identified in sort of the remote sensing part of the project. But they also want to understand why those gossains are there in the context of their regional geology. So like today, for example, Éloise and Gaëlle, they hiked across the lake to go and collect samples of the dike, which are not orange, just so that they can get the chemistry to compare with the rocks so that they have the whole picture. Hopefully that answers all of it.
Excellent. Thank you, Hannah, for those questions. We have a question from Sam, who says, awesome tour, really enjoying it. Says there seems to be a lot that goes into setting up the camp. How much planning goes into a trip like this?
Lots.
A lot of planning. I would say for one expedition, it takes about a whole year, with different steps, each one after the other. So we first had to get the money from CSA to allow us to come here and bring the students. So once that was done, the biggest part was checked. But after that, the real work began to organize the field trip in itself, which lasts 2.5 weeks, approximately 2 to 3 weeks. So the first step was to contact the Polar Continental Shelf Program, which carried us from Resolute to here. And then once that was done, we had to ask for a permit because we are in Nunavut, and we are preserving the land as much as possible. But we have to present our scientific project to the government of Nunavut, so they are aware of what we are coming here to do, and they have to approve it. And then once that's approved, we can get into the fieldwork logistics. So our students, Éloise and Gaëlle, were here this year, worked really hard to prepare all the food that we can bring, measure all the quantities, organize the recipes that we could cook. So we are mostly eating dried food, rehydrating our things. So they planned everything ahead of time, bought everything. We had to ship food ahead of time because it was too heavy to carry it with us. So we had 4 boxes of food that traveled and arrived here before us. And then everyone had to prepare their gear. We are hiking a lot, walking every day, climbing mountains, going downhill. We had to prepare for any kind of weather that could happen. Like last year, could have been wet, cold, warm and sunny, you never know. So we had to prepare for anything. And then science-wise, so we had to think ahead of time at the direction and distances that we wanted to cross by foot or with the helicopter originally, but it's been done mostly by foot this year. So yeah, there's been a lot of planning into this. What she said.
Perfect. Okay,
and Cass is amazing. So she's our field trip leader. So with her experience and her knowledge of the area, we could better prepare for this. So yeah, that was definitely key to help out with our preparation.
But I will add on to that saying I have an absolutely awesome team. They made it easy.
Teamwork makes the dream work. That's awesome. I'm mindful of our time, so we have 5 minutes until we have to let you go. So we'll try to get through a couple more of these questions. And I would say to anyone, if I don't get to your question, please feel free to reach out on our Twitter, our Facebook, our Instagram channels. I can definitely relay questions to Cass and the team after the fact if we don't get to them today. We have a question from Audrey who says, what would you say are the main risks associated with the expedition?
Oh, good question. Well, so weather we talked about, number one. Whether it becomes a risk at sort of every stage of the expedition during planning, getting into being in Resolute. Could we even get here? Finally, we're here. And then, I mean, we've been really lucky, but weather becomes an issue not only for a bunch of things. So power, being able to get home. So having the plane to come and get us, so we could get stuck here for weeks on end if the fog rolled in and decided to be really stubborn. And also when fog rolls in, you can easily, much easier stumble down a hill or not see wildlife coming at you because all the wildlife and the fog is all white. We did see an Arctic hare the other day. That was pretty awesome on the top of the hill. So.
Not too scary.
No, not too scary. You see something white moving and okay, it's just a hare. And then so the other risks are generally speaking wildlife, but we've taken the precautions. So the whole team has gotten remote first aid training, bear awareness training, helicopter safety training that they actually need, but actually it's handy for all kind of aircraft in general. Any other training do we do? I think those are the main three,
those
right?
are three, and they came into the year of preparation. I forgot about that.
And we repeat every year all of that. Other risks, we do have deterrents to be safe in the field. So we actually have four forms of deterrence. So if we did come to encounter wildlife, we can use a whistle. Things like wolves, they really don't like the high-pitched sound of whistles. And I have actually got to test this on a different expedition. They don't like it and they do run away. And then we have bear spray, bear bangers. So basically a flare that makes a big boom. And we also have a 12-gauge shotgun just in case as a very final last resort should we need it. And we have not needed it, thankfully. We haven't needed any of those things yet and hopefully won't. Any other risks that general risk, injury, general risks.
We try to be careful climbing up and down these steep slopes with rocky ground, basically. Often there are angular rocks that move around as we're walking. Sometimes the tundra has this rounded appearance and it's very easy to twist an ankle or something like that. So we try to be careful. We hike a lot, as Myriam said, but we try to go at a steady pace and we don't want to risk injuring anyone. But also, like was said, we've all had our remote first aid training if anything does go wrong. And we're always in radio contact with either camp and or Resolute. We have radios and we have satellite phones just in case. On the team at all times. I'll also say, so based on the we're at different ages and stages. And so for example, we had a little physio party in the kitchen last night and taped everybody's knees up for extra support.
I love that. That's not what you're expecting to learn about on something like this, but that's a great added detail. You know what? I think we may need to leave it there because I don't want us to get cut off. I know you have your radio check coming. So I want to thank everyone for tuning in. It's been really great. Thank you for your questions. I will be posting this to the museum's YouTube channel as soon as I'm able to get the audio and the video transcript done to go along with that for accessibility purposes. So if you missed a part of it or want to share it with someone, hopefully it should be up soon. I've put a link to the TMARS website in the chat as well. So if people are interested in checking out the project, please feel free to do that. And a huge thanks to Dr. Marion and the entire team for joining us and sharing the project, your experience. I know I can speak for myself anyway, but I think for everyone when I say it's just been really interesting and very cool to be able to talk to you from such a distance. So thank you so much.
Thank you, Ariane, and thank you for organizing. Thank you, everyone. Stay safe.
Bye, everyone.
Bye-bye.
Thank you.